Dear students, we can start our first physics chapter, that is chapter 11, force and pressure. I hope all of you love watching cartoons and all, cartoon movies and all. So we can start our chapter with an introduction from the cartoon characters. Once upon a time, Chota Bheem and Chotki were walking through a forest. They could find a cave which was closed with a rock door. So they tried to open the door by pushing. So who can open the door? Obviously, your answer will be Chota Bheem. The reason is he can apply more force than Chotki in order to push the door, isn't it? So our topic is force. We all love doing so many activities in our daily life, like kicking football, picking something from door floor, and hitting, and sometimes you fight with your friends, isn't it? In all these cases, you are applying the force. So many activities we are doing in our life. So we summarize these activities into two main actions, that are push and pull. In our first activity, some of the situations are given. You have to categorize these activities into push and pull. Okay, let's see. So this is the first activity given in the textbook. Some of the situations are given in the table. And here we have to write how many possible activities can be done to do this situation. First one, moving a book placed on a table. You can move some of the examples are given. We can push the book, pull the book, lift the book. All the three is already given in the textbook. So we can categorize these activities as push and pull. Pushing is also there. So we have written yes in this column. And pulling is also there. Yes. And lifting is also an example for pulling. Actually, lifting means we are pulling that. So that also can be written as pull. So we have done like, and here some of the examples are given. We have to categorize all these things. Opening or shutting a door. We can push to shut the door, and we can pull the door to open. We can shut the door also. So push and shutting can be categorized as push. So we can put yes in this column. And pull is also there. We can write yes in both cases. In this case, to open or shut a door, we can push as well as pull. Next, drawing a bucket of water from a well. Actually, it is lifting. Lifting means it's an example for pull. So in this case, pushing is not possible. So we have written yes in the column of pull. Next one, a football player taking a penalty kick. Actually, it's pushing, kicking, and I have written the pushing in that. Actually, it is pushing. So we can write yes here instead of here also we can write pull. So we have written no. These are other examples. All these are from our daily life. So you can write more, or other three you can do yourself. Okay. From this activity we can define force. Force is defined as push or pull on an object. In science, force can be defined as push or pull on an object. Once we define a quantity, we can define its units also. The unit of force is Newton. It is represented by capital N. The unit of force is Newton, and it is represented by capital N. Is it clear? Consider an example. I have drawn a table in the board. I am applying a force in this direction. So how we can represent the force? Let it be 5 Newton. 5 Newton. I am applying a force from this side on this book which is placed on the table in this direction. So what will be the result? As a result, the book will move towards this direction. Object will move in the direction of force acting on it. So the result is the book will move towards this direction. Is it clear? So force can be represented by a magnitude, a numerical value, and the unit. This numerical value, which gives the strength of the force, is called magnitude. For example, 10 Newton. Someone is applying 10 Newton. This numerical value, which gives the strength of the force, is called magnitude. And the symbol N represents the unit of the force. Is it clear? Suppose two or more forces are acting on an object. How we will calculate the total force acting on an object? Okay. So our aim is to find the total force or net force acting on an object. First case. This is a wooden block. One person is applying 5 Newton force in this direction. First person is applying 5 Newton in this direction. And it can be represented as F1. another person is also pushing this block from this direction, same direction. Both the persons are applying the same direction. Let it be F2. We can give a value 10 Newton. Then the net force acting on the object when two or more forces acting in the same direction will be the sum of the individual forces. So our total force acting on the object will be F equal to F1 plus F2. What will be the result in this case? 5 plus 10, that's equal to 15 Newton. What we are getting from this? If two or more forces acting on an object in the same direction, then the net force will be the sum of the individual forces. You just simply add the numerical values, that is the magnitude of the given forces, then you will get the total force acting on the object. Second case, one person is applying the force in this direction, let it be F1, 10 Newton. And another person is applying a force, we can represent by F2, let it be 6 Newton. Then the net force acting on the object will be difference between these two numbers. When two or more forces are acting on an object in the different direction or in opposite direction, then the result force acting on the object will be the difference in the two forces. Is it clear? So what will the answer here? Total force acting on the object will be difference between these two forces, because these two forces are acting in the opposite direction. So which is greater value 10 Newton minus 6 Newton. Then the result will be 4 Newton. So here the net force acting on the object will be 4 Newton. So the object will move in the direction of stronger forces. Which is the strongest force in this one? F1 is more stronger than F2, isn't it? So the object will move in the direction of 10 Newton. And the third case, this is not mentioned in your textbook, but it's an application level question. Two forces are acting on an object in opposite direction, but the net force acting on the object is 0. Then what we can infer from that situation? The answer will be both forces will be equal. The magnitude of both forces will be equal, but they are acting in opposite direction. For example, F1 is acting along this direction and F2 is acting along this direction. If F1 equal to F2, the net force, how will you calculate the net force? F equal to F1 minus F2. F1 and F2 are equal. Then F equal to F1 minus F2 equal to 0. That means the net force acting on the object will be 0. So what we can infer from this situation? If the two equal and opposite forces are acting on an object, the net force acting on the object will be 0. So the object will not move in the direction of force.